somewhere inside every atom in your body, hidden far beneath the scale of human sight, there is a storm so violent that it never truly rests. A storm without wind, without clouds, without sound. A storm made entirely of energy. And tonight, as we drift slowly into one of the strangest mysteries in modern physics, we are going to discover that the solid world around you may not be solid at all. The chair beneath you, the walls around you, the weight of your own body resting quietly against the earth, all of it may emerge from something far stranger than matter itself. If you watched our earlier journey into the strange emptiness hidden inside black holes, you may already suspect that the universe enjoys disguising reality beneath layers of illusion. And tonight, that illusion becomes even deeper. Welcome back to Velarin's Sleepy Space Mysteries, where we slowly wander through the quiet edges of science, space, and existence itself. Before we begin tonight's descent into the hidden interior of the Proton, take a moment to subscribe, leave a like, turn on notifications, and if you enjoy these long cosmic journeys, consider joining the channel membership to help support future explorations drifting out into the darkness. And somewhere out there beneath tonight's sky, wherever you are listening from, let us know in the comments where in the world you are watching from tonight. Now, close your eyes for a moment and imagine touching a stone resting beside a river. Feel solid, heavy, permanent. Your entire life has taught you that matter is made of tiny physical things packed together into objects. But the deeper physicists looked into reality, the stranger the truth became. Inside every proton, one of the tiny particles forming the nuclei of atoms, scientists discovered not a small solid sphere, but a restless ocean of quarks, gluons, and violent fields of trapped energy. Even more astonishing, almost all of the proton's mass does not come from the particles inside it. It comes from motion, from force, from energy itself, which means that the mass making up your body, the stars above you, and the ancient earth beneath your feet may be little more than energy held together in an endless cosmic storm. For most of human history, reality appeared simple. The world felt solid beneath our feet. The stars moved slowly overhead, rivers carved through stone, and every object seemed to possess a clear and obvious physical existence. A rock was a rock because it contained substance. Iron was heavy because it was filled with dense material. And the human body, fragile and temporary though it might be, still appeared to be constructed from countless tiny pieces of physical matter packed together into muscles, bones, skin, and blood. Long before science had instruments capable of peering into atoms, people trusted their senses completely. Solidity felt undeniable. Matter seemed permanent. Existence itself appeared stable and calm. But the deeper humanity looked into the structure of reality, the more unsettling the universe became. Every generation uncovered another hidden layer beneath the one before it, and each layer seemed stranger than the last. Ancient philosophers once imagined that all matter was built from simple elemental substances like earth, water, air, and fire. Later, early atomists proposed that everything might instead be made from indivisible particles too small to see. Thousands of years passed before science finally confirmed that atoms truly existed. Yet even then, the atom itself appeared at first to be a tiny solid object, a miniature billiard ball drifting invisibly through the universe. That comforting image survived only briefly. When physicists first cracked open the atom, they discovered something deeply disturbing. The atom was not solid at all. It was almost entirely empty space. A tiny nucleus rested at the center while electrons drifted impossibly far away around it, leaving vast regions of nothingness between them. If an atom were expanded to the size of an enormous cathedral, the nucleus at its center would still be smaller than a grain of sand. Everything else would be emptiness. Silent emptiness stretching outward in every direction. And yet, despite this overwhelming void, matter still felt solid to human hands. Tables resisted pressure. Stone bruised skin. Mountains crushed anything beneath them. Somehow emptiness created solidity. Somehow nearly non-existent particles generated the illusion of substance. Even now, scientists still pause when considering how profoundly strange this truly is. Every object surrounding you at this very moment is built mostly from absence. The sensation of touch itself emerges not because atoms physically collide, but because invisible electromagnetic fields repel one another before direct contact ever occurs. You have never truly touched anything in the way your brain believes you have. Every sensation of contact throughout your entire life has been force interacting with force across microscopic emptiness. And yet the mysteries only deepened further once physicists turned their attention toward the nucleus itself. Hidden inside the center of every atom were protons and neutrons, tiny particles once believed to be fundamental building blocks of reality. For a brief moment in scientific history, it seemed the journey had finally reached the bottom. Perhaps these particles were the final indivisible pieces from which everything else emerged. But nature refused to remain simple. As particle accelerators grew more powerful during the 20th century, scientists discovered an entire hidden world inside the proton itself. Instead of being a smooth sphere of matter, the proton contains smaller entities called quarks, bound together by unimaginably powerful gluon fields. What had once appeared fundamental turned out to contain another universe beneath it. And within that hidden universe, the laws of reality began behaving in ways almost impossible for human intuition to accept. Inside the proton, quarks move at speeds approaching the speed of light itself. Gluons flash endlessly between them, carrying the strongest known force in existence. New particles emerge briefly from pure energy before vanishing again almost instantly. Nothing inside the proton is still. Nothing rests. It is less like a solid object and more like an eternal storm trapped within impossibly tiny boundaries. Even stranger, the quarks themselves contribute almost none of the proton's total mass. This is the revelation that shook modern physics to its core. Scientists measured the masses of the quarks individually and discovered that together they account for less than 1% of the proton's weight. Less than 1%. The remaining mass, the mass making up nearly everything visible in the universe, arises from something else entirely. From motion, from confinement, from energy trapped within the violent turbulence of the strong force itself. In other words, the weight of your body is not primarily the weight of particles. It is the weight of energy held captive inside atomic nuclei. The universe you experience as stable matter may actually be a vast ocean of vibrating energy patterns masquerading as solidity. And as we continue drifting deeper into this mystery tonight, we will slowly uncover how the proton became one of the greatest clues humanity has ever found about the true nature of existence itself. The deeper scientists investigated the proton, the more reality seemed to abandon ordinary logic altogether. In daily life, objects behave in ways our minds can easily understand. If you pull two things apart, the connection between them weakens. A rope stretches thinner. Gravity fades with distance. Even magnets lose strength when separated far enough. Human intuition is built upon this pattern because nearly every force we encounter behaves that way. Distance weakens connection. Separation reduces influence. But inside the proton, nature follows an entirely different rule, one so strange that when physicists first discovered it, many struggled to believe the mathematics themselves. The force holding quarks together becomes stronger as the quarks move farther apart. Not weaker, stronger. Imagine trying to stretch an invisible elastic band connecting two particles, only to discover that the farther you pull, the more violently the band resists. This bizarre behavior belongs to the strong nuclear force, the most powerful force known anywhere in the universe. It is so overwhelmingly intense that gravity, by comparison, becomes almost irrelevant at subatomic scales. The same gravity capable of shaping galaxies and collapsing stars into black holes is utterly powerless against the force raging inside a proton. And yet this immense force remains hidden from ordinary human experience because its range is astonishingly small. It dominates only across distances smaller than an atomic nucleus itself. Beyond that scale, it fades almost completely, imprisoned within matter like an invisible storm trapped beneath the surface of reality. But inside the proton, the strong force never rests. Quarks continuously exchange gluons, strange particles carrying what physicists call color charge. Despite the name, this has nothing to do with visible colors. It is simply the language scientists use to describe how the strong interaction behaves. Gluons bind quarks together so tightly that no quark has ever been isolated by itself anywhere in nature. Every attempt to separate one only creates more particles from the energy being poured into the system. This is one of the strangest discoveries in modern physics. If enough energy is forced into empty space, new matter can emerge directly from that energy itself. Reality begins manufacturing particles out of pure force. The universe does not merely contain matter. Under the right conditions, energy becomes matter. This transformation lies at the very heart of the proton's mystery. Deep inside the proton, gluons race back and forth endlessly at nearly the speed of light. Temporary quark pairs flicker into existence and vanish again almost instantly. The interior resembles a boiling ocean more than a stable object. Physicists sometimes describe these fleeting particles as sea quarks, because they surge constantly beneath the permanent quarks defining the proton's identity. At any given instant, countless invisible interactions unfold within a region smaller than a trillionth of a millimeter. It is chaos contained inside precision, violence hidden inside stability. The proton appears calm only because human perception operates far too slowly to witness the turbulence underneath. In truth, every proton surrounding you right now contains a storm older than civilization itself. A storm that has never once become silent since the early universe first cooled enough for matter to form. And perhaps the strangest part of all is this: the energy trapped within that storm becomes mass. This realization emerged from one of the most famous insights in scientific history, Albert Einstein's understanding that mass and energy are not separate things at all. They are different forms of the same underlying reality. Matter can become energy. Energy can become matter. The distinction human beings once imagined between solid substance and invisible force slowly dissolved beneath modern physics. When you hold a stone in your hand, most of its weight does not come from tiny particles carrying intrinsic heaviness. Instead, its mass arises largely from confined energy trapped inside countless protons and neutrons. The proton itself behaves almost like a prison of energy whose confinement generates weight. Without the violent motion of quarks and gluons, ordinary matter would lose nearly all of its mass. This means the physical world is far stranger than even most educated people realize. Every mountain, ocean, tree, animal, and human body is constructed mostly from invisible energy fields interacting with one another inside atomic nuclei. The solidity you experience every day emerges from trapped motion and invisible forces. You are not simply made of particles. You are made from organized storms of energy held together across unimaginable scales of emptiness. And this strange revelation quietly changes the meaning of existence itself. Human beings often imagine themselves as solid creatures living within a stable physical universe. But beneath the surface, stability is only an illusion emerging from endless microscopic turbulence. Reality is dynamic at every scale. The atoms inside your body are ancient cosmic events frozen temporarily into form. The proton itself contains echoes of the early universe, preserving conditions that once filled all of space shortly after the birth of time. Every breath you take depends on invisible storms raging endlessly beneath the threshold of perception. And somewhere inside that hidden turbulence may lie deeper answers about why matter exists at all, why the universe chose structure over emptiness, and why energy itself became capable of forming stars, planets, oceans, and eventually conscious minds able to wonder where all of this came from in the first place. If all of this begins to feel less like physics and more like philosophy, that is because modern physics slowly carried humanity into questions once reserved only for ancient mystics and dreamers. For thousands of years, people wondered whether the world we experience is truly the world that exists beneath appearances. The proton unexpectedly became one of the clearest answers ever discovered. Reality at its deepest levels does not resemble the solid world perceived by human senses. Instead, it behaves more like an endless symphony of invisible interactions unfolding across oceans of emptiness. Matter survives not because it is static, but because motion itself becomes stable. Energy loops into patterns. Forces trap one another into delicate balances. Tiny storms become atoms. Atoms become stars. Stars forge heavier elements in their burning interiors, scattering them outward into space where planets eventually form. And on at least one small world drifting quietly around an ordinary star, those ancient particles slowly assembled into living creatures capable of wondering why the universe exists at all. There is something strangely beautiful about realizing that every atom inside your body was shaped by events stretching back billions of years before human civilization ever appeared. The protons inside your bloodstream are ancient beyond imagination. Many of them formed during the first few minutes after the Big Bang itself, when the newborn universe remained so hot and dense that matter barely existed in recognizable form. In those earliest moments, reality resembled a cosmic firestorm where particles constantly emerged and vanished within blinding temperatures. Quarks moved freely through vast seas of energy because the young universe was too hot for protons to exist yet. Only later, as space expanded and cooled, did the strong force begin locking quarks together into stable particles. The proton emerged from that cooling chaos like a tiny island of stability forming within an ocean of fire. Every proton alive today carries the memory of that ancient transformation. In a very real sense, the matter composing your body was forged from the cooling aftermath of creation itself. And yet, even now, scientists still struggle to fully understand the proton's interior. This is partly because the equations governing the strong force are among the most difficult in all of science. Unlike gravity, which can often be approximated cleanly, or electromagnetism, whose behavior becomes predictable across many situations, the strong force behaves with overwhelming complexity. Gluons interact not only with quarks but with each other as well, producing endless chains of turbulent interactions. Inside the proton, reality becomes so chaotic that exact solutions remain nearly impossible using ordinary mathematics alone. To explore these hidden interactions, physicists built enormous supercomputers capable of simulating tiny regions of space-time itself. These simulations divide space into microscopic grids and calculate the behavior of quarks and gluons point by point, interaction by interaction, over unimaginable numbers of calculations. Some computations require months of continuous processing using machines among the most powerful humanity has ever created. And slowly, through those vast calculations, the proton revealed its secret. Scientists discovered that the equations of the strong force naturally generate nearly the exact mass observed in real protons. No hidden particles were needed. No mysterious, unknown substance was required. The energy trapped inside the proton truly does create almost all of its weight. This was one of the greatest confirmations in modern physics because it demonstrated something astonishing about reality itself. Mass is not simply an inherent property of matter. In many cases, mass emerges dynamically from energy interactions occurring within quantum fields. The universe generates substance from activity, weight from motion, form from confinement. And once this realization settles into the mind, the ordinary world begins feeling subtly transformed forever afterward. Look around the room you are sitting in tonight. Every object surrounding you appears calm and unmoving. Perhaps there is a wall nearby resting silently in darkness. Perhaps there is rain outside your window or the distant sound of traffic moving somewhere beyond the night. Everything feels stable, permanent, but hidden beneath that stillness, every atom remains alive with unimaginable motion. Quarks race through protons at near light speed. Electrons drift through quantum clouds impossible to pin down precisely. Gluon fields stretch and collapse continuously inside atomic nuclei. Temporary particles emerge briefly from vacuum fluctuations before disappearing again. The universe is never still. Stillness itself may only be an illusion generated by scales too small and too fast for human senses to perceive directly. This realization can feel unsettling at first, but there is also comfort hidden inside it. The cosmos is not a dead mechanical machine built from lifeless blocks of matter. It is active, dynamic, restless. Every piece of reality participates in an ongoing dance of energy and transformation. Even emptiness is not truly empty. Quantum fields permeate all of space, vibrating quietly beneath existence like invisible oceans extending throughout the universe. The proton, once imagined as a tiny solid sphere, became a doorway into that deeper understanding. By studying one of the smallest particles inside ordinary matter, humanity uncovered evidence that reality itself may be woven from fields, interactions, probabilities, and trapped energy rather than miniature physical objects sitting motionless in space. And perhaps this is why the proton continues to fascinate physicists even after decades of study. It reminds us that nature never becomes simpler the deeper we look. Each layer opens into another mystery waiting underneath. First, the atom seemed fundamental. Then the proton replaced it. Then quarks and gluons appeared beneath the proton. And somewhere beyond even those structures, deeper questions still remain unanswered tonight. Questions about why quantum fields exist at all. Why the strong force possesses exactly the strength it does. Why energy became capable of forming stable matter rather than dissolving into chaos forever. The proton solved many mysteries, but it also opened the door toward even larger ones waiting quietly in the darkness beyond the edge of human understanding. There is one final idea we must slowly approach before leaving this stage of the journey, because without it, the mystery of the proton remains incomplete. We have spoken about quarks racing through invisible storms, about gluons binding reality together with unimaginable force, and about mass emerging from trapped energy rather than from solid substance alone. But hidden beneath all of these discoveries lies an even stranger realization, one that quietly transformed the way physicists think about the universe itself. The proton is not merely an object existing inside space. In many ways, it is an event unfolding continuously through time. This distinction may sound subtle at first, but it changes everything. Human intuition naturally imagines matter as something static. A stone appears identical from one second to the next. A mountain seems permanent across centuries. Even our own bodies feel stable as we move through daily life. But at the quantum level, stability is not created through stillness. It emerges from ceaseless activity repeating itself in organized patterns. The proton survives not because nothing changes inside it, but because its turbulence remains balanced in a stable form. It is more like a flame than a pebble. A flame appears constant when viewed from afar, yet every instant new particles enter and leave it. The structure persists even while the contents continuously change. In a similar way, the proton remains recognizable while its internal sea of quarks and gluons churns endlessly without rest. This insight becomes especially haunting when we remember that nearly every atom in your body depends upon this balance remaining intact. The calcium inside your bones, the oxygen flowing through your blood, the carbon woven into every cell of your body. All of it relies upon protons maintaining their stability across billions of years. If the strong force were even slightly weaker, quarks could not remain confined tightly enough to form stable nuclei. Matter itself might collapse into simpler particles incapable of forming chemistry. If the strong force were slightly stronger, stars would burn differently, nuclear reactions would shift, and the universe might never produce the diversity of elements required for planets and life. The proton sits within an extraordinarily delicate balance of physical laws, balanced so precisely that tiny changes could erase the possibility of human existence entirely. And yet, despite this delicate precision, the proton itself remains astonishingly resilient. Scientists have searched carefully for evidence that protons eventually decay into lighter particles over immense timescales. So far, no confirmed proton decay has ever been observed. Current experiments suggest that a proton's lifetime may exceed 10 to the 34th years. That number is so large it barely fits inside ordinary imagination. It is trillions upon trillions of times longer than the current age of the universe itself. Pause for a moment and consider what that means. The protons inside your body tonight may continue existing long after every star in the sky has burned dark. Long after galaxies drift apart into cold cosmic isolation. Long after black holes evaporate slowly through Hawking radiation into faint traces of heat. If proton decay truly occurs, it unfolds so slowly that matter itself becomes almost eternal on human scales. The atoms forming your body are temporary arrangements, but many of the protons within them may outlive entire cosmic eras yet to come. There is something deeply humbling about this realization. Human lives feel long from the inside, yet compared to the lifespan of the particles composing us, we are flickers. Brief arrangements of ancient matter temporarily conscious before dissolving back into larger cycles of existence. And still, physicists continue probing deeper because unanswered mysteries remain hidden inside the proton even now. One of the greatest involves something called proton spin. Early experiments suggested that the spins of the proton's three primary quarks should combine neatly to produce the proton's overall spin. But when scientists measured the numbers carefully, they discovered something shocking. The quarks contributed only a fraction of the proton's total spin. Once again, most of the expected property seemed missing. The proton repeated its old trick. Just as most of its mass emerged from hidden energy rather than from the quarks alone, much of its spin also appeared distributed through the restless motions of gluons and sea quarks swirling inside. Even after decades of research, physicists still debate precisely how the proton's internal dynamics generate its observable properties. The deeper we look, the less the proton resembles a simple particle and the more it resembles a self-organizing quantum ecosystem of interacting fields and energies. Perhaps that is the true lesson hidden inside tonight's journey. Reality does not become simpler beneath the surface. It becomes richer, stranger, and more interconnected than human intuition ever expected. The proton began as a tiny point inside the atom, something once imagined to be solid and indivisible. But layer by layer, it unfolded into an entire hidden cosmos of motion, confinement, quantum fields, and trapped energy. And through that journey, modern physics uncovered a truth both unsettling and strangely beautiful. Matter is not built from tiny eternal objects resting silently in empty space. Matter emerges from relationships, from interactions, from energy patterns stabilizing themselves across time. The universe is less like a machine made from rigid components and more like a vast symphony of vibrations woven together into temporary forms. So tonight, as you slowly drift deeper into sleep and the distant stars continue their silent motion overhead, remember this quiet mystery hidden inside every atom around you. Beneath the appearance of stillness, reality is alive with movement. Beneath every solid object waits an invisible storm. And somewhere inside the proton, inside the tiny ancient particles quietly composing your body at this very moment, the universe continues its endless dance of energy and existence, unfolding silently in darkness just beyond the reach of ordinary human perception. There is a quiet irony hidden at the heart of human existence. The more carefully we study the smallest structures in the universe, the more fragile our ordinary assumptions about reality begin to feel. For centuries, people believed that permanence belonged to solid objects while motion belonged only to living things or flowing forces like rivers and wind. A mountain appeared eternal because it did not visibly move. Stone represented stability. Matter itself seemed dependable because human senses could not perceive the microscopic chaos unfolding beneath appearances. But the proton slowly dismantled that comforting illusion. Beneath every object you have ever touched lies endless movement, invisible turbulence unfolding so rapidly and at such tiny scales that the human brain smooths it into the illusion of stillness. In truth, the universe may never have contained stillness at all. Reality appears calm only because our senses are too slow to witness its deeper activity directly. Even empty space itself no longer appears truly empty to modern physics. This realization emerged gradually as scientists explored quantum fields, the invisible structures believed to permeate all of existence. According to quantum theory, every type of particle corresponds to an underlying field stretching throughout the cosmos. Electrons arise from electron fields. Quarks emerge from quark fields. Photons emerge from electromagnetic fields. The proton, once imagined as a tiny independent object, is now understood more as a temporary knot forming within these deeper fields. Quarks and gluons are not miniature marbles drifting through emptiness. They are excitations, disturbances rippling through underlying quantum structures filling all of spacetime itself. In some sense, matter resembles waves appearing briefly on the surface of a much deeper invisible ocean. This idea becomes easier to imagine if you think of the surface of the sea at night. From far away, individual waves appear like separate objects moving across the water. But no wave exists independently from the ocean beneath it. The wave is simply a pattern temporarily emerging from the motion of the larger system. In a similar way, protons may not be standalone things in the traditional sense. They are stable patterns emerging from the deeper behavior of quantum fields interacting with one another. The quarks inside the proton cannot even be fully separated from the gluon fields surrounding them because the field itself helps define what the proton actually is. Everything blends together into one inseparable quantum process. And this changes the ancient question humans once asked about what matter is ultimately made of. Perhaps reality is not built from objects at all. Perhaps it is built from relationships, interactions, and vibrations occurring within deeper fields underlying the visible universe. Strangely enough, this view aligns in unexpected ways with certain philosophical ideas that appeared long before modern science existed. Ancient thinkers across multiple civilizations often suspected that permanence might be an illusion generated by deeper forms of change. Some described reality as a flowing process rather than a collection of static objects. Others believed the visible world emerged from hidden underlying principles impossible to observe directly. Of course, ancient philosophies did not possess particle accelerators or quantum mathematics. Their ideas came through intuition and contemplation rather than experiment. Yet it remains fascinating that modern physics, after centuries of studying matter itself, eventually arrived at a vision of reality where invisible activity beneath appearances becomes more fundamental than the appearances themselves. And nowhere is this hidden activity more extreme than inside the proton. Remember what we uncovered earlier. The quarks themselves contribute less than 1% of the proton's total mass. Nearly everything else comes from dynamic energy trapped within the strong interaction field. The proton behaves almost like a microscopic storm system, maintaining its stability through continuous motion. If that motion ceased, the proton as we know it would vanish. In this sense, matter survives through activity rather than through stillness. The universe preserves structure not by eliminating chaos, but by organizing chaos into repeating stable forms. Galaxies form from gravitational turbulence. Stars survive through constant nuclear fusion. Life persists through endless chemical activity inside cells. And the proton itself endures through an eternal dance of confined quantum energy unfolding beneath ordinary perception. Perhaps this is why particle physicists sometimes speak about beauty when describing equations governing the universe. From the outside, science often appears cold and mechanical, filled only with calculations and measurements. But beneath those calculations lies a growing recognition that reality possesses astonishing elegance. Tiny adjustments in the laws of physics would erase atoms completely. Slightly different values for the strong force could prevent stars from forming stable elements. A weaker electromagnetic interaction might make chemistry impossible. The proton itself exists only because multiple quantum processes balance each other with extraordinary precision. Too much energy and the proton destabilizes. Too little and quarks cannot remain confined properly. Nature somehow found a narrow pathway through infinite possibilities, allowing complexity to emerge gradually across billions of years. And yet, even with all these discoveries, physicists know their understanding remains incomplete. The proton still hides unanswered questions within its interior. Scientists continue investigating whether deeper layers exist beneath quarks themselves. Some theories suggest quarks may eventually prove composite rather than fundamental. Others propose entirely new quantum structures beyond current models of physics. There are still mysteries surrounding dark matter, dark energy, and the unification of gravity with quantum mechanics. Humanity stands not at the end of understanding, but perhaps only near the beginning. Every answer uncovered by science seems to open new corridors of uncertainty waiting quietly beyond it. The proton, once thought simple, became an entire universe of hidden complexity. And somewhere beyond that complexity, deeper mysteries continue sleeping silently in the dark, waiting for future generations to slowly awaken them. One of the strangest consequences of everything we have explored tonight is that the universe begins to feel less like a collection of objects and more like a conversation unfolding between invisible fields. At the human scale, we naturally divide reality into separate things. A tree stands apart from the soil beneath it. A person seems separate from the air surrounding them. A planet drifts independently through empty space. Human language itself evolved to describe stable objects because our brains depend upon categories to survive. But the proton quietly challenges this entire framework. Inside it, nothing exists independently for long. Quarks cannot survive without gluons. Gluons continuously create temporary particles from energy. Fields overlap and influence one another constantly. The boundaries separating one thing from another begin dissolving the deeper we look. Reality behaves less like isolated building blocks and more like interconnected patterns woven together across space and time. This interconnectedness becomes especially mysterious when quantum mechanics enters the picture fully. Quantum theory revealed that particles do not possess perfectly definite properties in the ordinary sense human intuition expects. Instead, many properties exist only as probabilities until interactions force specific outcomes to emerge. An electron inside an atom does not orbit neatly like a planet circling a star. It exists as a spread-out quantum possibility cloud. Even inside the proton, quarks cannot be assigned perfectly fixed positions the way classical objects can. Their locations and motions blur into fluctuating probabilities governed by quantum uncertainty. The proton therefore becomes not only a storm of energy, but also a storm of possibilities constantly shifting beneath observation itself. This uncertainty troubled many physicists when quantum mechanics first emerged during the early 20th century. Einstein himself resisted some of its implications because the universe it described felt profoundly counterintuitive. The idea that reality might not possess definite measurable properties until interactions occur seemed almost absurd compared to classical physics. And yet experiment after experiment confirmed the strange predictions of quantum theory with astonishing precision. The deeper humanity probed nature, the more the universe refused to behave like a simple mechanical machine. Instead, reality revealed itself as something subtler, stranger, and far more fluid than anyone had imagined before. And perhaps nowhere does this become more haunting than when we remember that your own body participates fully in this hidden quantum world. Every heartbeat, every breath, every thought emerging inside your mind depends upon quantum interactions unfolding continuously within atoms and molecules. The neurons inside your brain function because electrons obey quantum rules. The protons inside those atoms carry ancient storms of confined energy stretching back toward the beginning of time itself. Human consciousness, which feels so immediate and personal, emerges from layers of invisible physical processes unfolding beneath awareness every second. The proton may seem unimaginably small, yet your existence depends upon its stability completely. There is also something deeply poetic about the timescales involved. Human civilization measures history across centuries. Ancient monuments feel old because they survived a few thousand years. Mountains appear eternal because they outlive human generations. But the proton exists on a scale of permanence so immense that ordinary historical thinking becomes meaningless beside it. The protons inside your body may have survived since the first moments after the Big Bang nearly 14 billion years ago. They traveled through ancient stars long before Earth existed. They endured supernova explosions scattering heavy elements across interstellar space. They drifted through giant molecular clouds where new solar systems formed. Eventually, after billions upon billions of years of cosmic evolution, some of those ancient particles became part of oceans, rocks, forests, animals, and eventually you. This realization quietly dissolves the illusion that human beings are somehow separate from the wider cosmos. The proton reveals continuity everywhere. The atoms composing your body were not manufactured independently at birth. They were borrowed temporarily from a universe already unimaginably ancient. Even now, your body continuously exchanges particles with the environment around you through breathing, eating, drinking, and countless microscopic interactions occurring every moment. Matter flows endlessly through larger cycles of transformation. The proton remains stable while arrangements around it change continuously. In this sense, permanence and impermanence coexist together. The particles survive while the structures they compose transform endlessly across time. And still, despite all modern discoveries, scientists remain aware that today's understanding may eventually prove incomplete as well. History repeatedly demonstrated that every final model of reality eventually gave way to deeper layers underneath. The atom once appeared indivisible. Then the nucleus replaced it. Then protons and neutrons yielded to quarks and gluons. Now physicists search for theories capable of unifying quantum mechanics with gravity itself, one of the greatest unresolved problems in science. Some approaches suggest reality may involve vibrating strings smaller than particles. Others propose hidden dimensions curled invisibly beneath observable space. There are even theories suggesting spacetime itself may emerge from deeper quantum relationships, much the way matter emerges from fields and energy. The proton, therefore, occupies a strange position in modern thought. It is both deeply understood and profoundly mysterious at the same time. Scientists can calculate many of its properties with astonishing accuracy, yet fundamental questions remain unresolved beneath the surface. Why do the laws of physics possess exactly the values they do? Why does confined energy produce stable matter so effectively? Why does the universe allow complexity to emerge at all rather than collapsing into chaos or emptiness? The proton cannot answer these questions directly, but it points toward them constantly, like a doorway left slightly open into deeper layers of reality still waiting beyond current human understanding. And perhaps that is what makes tonight's journey feel so strangely calming despite its unsettling implications. The deeper humanity looks into the universe, the more mystery expands rather than disappears. Science does not erase wonder. It deepens it. Beneath every answer waits another question sleeping quietly in darkness. Beneath every solid object waits hidden motion. Beneath every proton waits an invisible storm older than stars themselves. And somewhere inside that endless unfolding complexity, human beings continue searching softly through the night, trying to understand how a universe built from invisible energy somehow became capable of creating minds that can stare back into the cosmos and wonder what it all means. As humanity continued exploring the hidden interior of matter, physicists eventually realized something deeply unsettling about their own role in observing reality. At the scales where protons, quarks, and quantum fields exist, the act of observation itself becomes impossible to separate completely from what is being observed. In everyday life, this seems absurd. You can look at a tree without changing the tree. You can watch rain falling outside your window without influencing the storm itself. Human intuition assumes that reality exists independently in a fixed state whether anyone observes it or not. But the quantum world does not always behave this way. To examine something as tiny as a quark, scientists must strike it with particles carrying enormous energy. And those collisions inevitably disturb the system being measured. The deeper humanity tries to peer into reality, the more violently reality reacts to being examined. This became especially important during experiments designed to probe the interior of the proton. High-energy electrons fired into protons revealed that quarks behave almost like free particles at extremely short distances, a phenomenon known as asymptotic freedom. Earlier in our journey, we explored the strange fact that the strong force grows stronger as quarks move farther apart. But at extremely tiny distances, the opposite occurs. The force weakens enough that quarks briefly behave as though they are nearly independent. This bizarre behavior helped physicists uncover the proton's internal structure in the first place. Yet it also revealed something remarkable about nature. The laws governing reality can reverse depending on scale. Forces behave one way across ordinary distances and another way entirely deep inside atomic nuclei. Human intuition evolved for survival at everyday scales, not for understanding the microscopic architecture of the universe. And still, despite all these strange discoveries, the proton somehow remains astonishingly stable. Imagine the chaos unfolding inside it at every instant. Gluons collide and multiply endlessly. Temporary particles appear and vanish continuously. Quarks race at near light speed inside an impossibly confined volume. By all ordinary expectations, such violence should produce instability. Yet the proton persists with extraordinary reliability across cosmic timescales. In fact, without this stability, stars could never maintain long-term nuclear reactions. Chemistry would collapse. Life itself would become impossible. Somehow the universe transformed microscopic turbulence into enduring order. This may be one of the deepest patterns repeated throughout nature. Stability does not emerge from eliminating chaos. Stability emerges from balancing chaos carefully enough that larger structures can survive within it. You can see echoes of this principle everywhere once you begin noticing it. A hurricane appears structured from afar even while containing violent turbulence internally. Living organisms maintain stability only through endless chemical reactions occurring inside cells every second. Entire galaxies survive through gravitational interactions involving billions of stars moving continuously through space. The proton belongs to the same family of cosmic structures. It survives not because it is static, but because its internal energies remain trapped within a delicate balance maintained by the laws of quantum physics. Nature seems capable of building permanence from motion itself. There is also something profoundly humbling about how small the proton truly is compared to the vast consequences emerging from it. A single proton measures roughly 1 femtometer across, a scale so tiny that millions of protons could fit within the width of a human hair. And yet, everything visible in human civilization depends upon particles operating at this microscopic level. Every cathedral ever built, every symphony ever composed, every memory carried within a human mind, every ocean wave beneath moonlight, every city glowing softly at night from orbit. All of it depends ultimately upon invisible quantum structures hidden inside atoms. Entire worlds emerge from interactions occurring far beyond direct human perception. And perhaps that is why studying the proton often produces a strange emotional effect on those who spend years thinking about it deeply. The world begins to feel simultaneously smaller and larger at the same time. Smaller because familiar objects lose their apparent solidity and reveal hidden emptiness beneath them. Larger because even the tiniest particle opens into layers of complexity vast enough to occupy generations of scientific exploration. The proton teaches humility. It reminds humanity that reality does not owe us simplicity. The universe is under no obligation to match the limits of human intuition. Instead, it unfolds according to principles far stranger and more beautiful than ordinary perception alone could ever predict. Modern particle accelerators continue pushing deeper into these mysteries even now. At facilities like CERN near Geneva, scientists accelerate particles to enormous energies before smashing them together in carefully monitored collisions. For tiny fractions of a second, conditions resembling those of the early universe briefly reappear inside these experiments. Quarks and gluons break free momentarily from their usual confinement, forming exotic states of matter known as quark-gluon plasma. In these fleeting moments, physicists glimpse something astonishing. The universe as it existed shortly after the Big Bang before protons fully formed. Reality temporarily returns to a more primitive state where matter itself becomes fluid and unstable. These experiments reveal that the proton is not merely a static object surviving since the dawn of time. It is also a fossil carrying memories of the universe's earliest moments. Inside every proton rests evidence of conditions existing when the cosmos itself was young beyond imagination. In this sense, every atom around you contains traces of ancient cosmic history hidden invisibly beneath ordinary matter. The proton becomes both particle and archive, preserving clues about how structure first emerged from primordial energy billions of years ago. And yet, even after all these discoveries, the deepest mystery may remain untouched. Why does anything exist at all instead of nothing? Why do quantum fields fill the vacuum rather than absolute emptiness? Why do the laws of physics allow energy to organize itself into stable matter capable of producing stars, planets, oceans, and conscious minds? The proton cannot answer these questions directly, but it points toward them constantly. Every layer uncovered inside matter reveals another layer waiting beyond it. Every answer opens further mysteries stretching deeper into darkness. And perhaps that endless unfolding is not a flaw in human understanding, but part of the universe's nature itself. An infinite depth where every discovery becomes the beginning of another journey still waiting quietly ahead. As our journey slowly approaches the final horizon, there is one last perspective we must consider, because without it the story of the proton remains unfinished. We have explored the proton as a storm of quarks and gluons, as trapped energy masquerading as matter, as a relic from the early universe, and even as a doorway into deeper mysteries about reality itself. But there is another strange truth hidden quietly beneath all these discoveries. The proton does not merely reveal how the universe works. It also reveals something profound about humanity's place inside the cosmos. For most of history, people imagine themselves standing apart from nature, observing the universe from a distance as though reality were a stage and human beings were the audience. Yet the deeper physics progressed, the harder this separation became to maintain. The atoms composing your body are not foreign to the universe around you. They are the universe, temporarily organized into a form capable of awareness. The proton quietly dissolves the boundary between observer and observed. Every proton inside your body has traveled through unimaginable stretches of cosmic history before becoming part of you. Some may have formed within the first few minutes after the birth of the universe itself, surviving nearly 14 billion years of cosmic evolution. Others may have passed through ancient stars that exploded long before Earth existed. Those particles drifted silently through interstellar darkness, mixed into clouds of gas and dust, and eventually became part of oceans, mountains, forests, and living creatures. Right now, as you listen quietly in the dark, ancient particles born near the beginning of time continue moving invisibly inside your bloodstream. Human life feels immediate and personal from within, but physically speaking, Every person is part of a much larger continuum stretching across cosmic history itself. And perhaps this is what makes the proton feel strangely emotional despite belonging to the world of physics. At first glance, it seems impossibly distant from ordinary human concerns. Tiny particles hidden inside atomic nuclei hardly appear connected to questions about existence, meaning, or consciousness. Yet the proton slowly changes how those questions feel. It reveals that human beings are not isolated from the cosmos observing it from outside. We are expressions of the same underlying reality. The energy trapped inside protons became stars. Stars forged heavier elements. Those elements formed planets. And on at least one small world orbiting an ordinary star, chemistry slowly evolved into biology, biology into awareness, and awareness into minds capable of wondering where everything came from. In a very real sense, the universe became conscious enough to examine itself. There is something deeply peaceful about that realization. Human beings often feel small beneath the enormity of space. Galaxies stretch across incomprehensible distances. Black holes consume stars. Time itself extends billions of years beyond ordinary imagination. Against such scales, individual lives can appear fragile and insignificant. But the proton offers another way to see things. The same laws governing distant galaxies also govern the atoms inside your body. The same forces shaping the early universe continue operating within every proton surrounding you tonight. You are not separate from cosmic history. You are woven directly into it. Every breath connects you to processes billions of years old. Every atom inside you carries the memory of ancient stars and primordial fire. And still, despite all humanity has discovered, the deepest mysteries remain unsolved. Physicists continue searching for a theory capable of uniting quantum mechanics with gravity, two frameworks that describe reality brilliantly in their own domains yet resist complete reconciliation with one another. Dark matter still surrounds galaxies invisibly, outweighing ordinary matter while remaining fundamentally unknown. Dark energy appears to drive the accelerating expansion of the universe itself, yet its nature remains mysterious. Even the proton, one of the most studied particles in all of science, still hides unanswered questions regarding its internal structure, its spin, and the deeper origin of the forces shaping it. Knowledge continues expanding, but so does mystery. Perhaps that endless mystery is not something to fear. Perhaps it is part of what makes the universe beautiful. A fully explained cosmos might eventually feel static and lifeless, like a solved puzzle with nothing left to discover. But reality does not behave that way. Every answer opens new questions waiting quietly beneath it. Every deeper layer reveals further depths still hidden beyond current understanding. The proton itself demonstrated this perfectly. What once appeared to be a tiny solid particle unfolded into a vast invisible world of fields, probabilities, confined energy, and quantum storms. And somewhere beneath even those discoveries, deeper truths may still remain asleep in darkness, waiting for future minds to uncover them slowly across centuries yet to come. So tonight, as the world around you grows quieter and your thoughts begin drifting softly towards sleep, remember the hidden universe resting inside every atom surrounding you. Remember that beneath the appearance of stillness, reality moves endlessly in silence. Quarks race through invisible storms. Gluons bind matter together with impossible force. Energy becomes mass. Empty space hums quietly with quantum fields stretching across the cosmos. And inside your own body, ancient protons born near the dawn of time continue their endless dance, carrying within them the memory of a universe still unfolding. Beyond your window, the stars continue shining across vast oceans of darkness. Beneath those stars, the Earth turns quietly through space, and somewhere deep inside the smallest particles of matter, storms of invisible energy continue raging silently, holding together the fabric of everything you have ever known. The proton may be unimaginably tiny, but hidden inside it lies one of the greatest revelations humanity has ever uncovered. The world is far stranger, far more dynamic, and far more deeply connected than our senses ever allowed us to imagine. And perhaps, in the quiet hours of the night, that realization becomes less frightening and more comforting, because it means that beneath all appearances, beneath every human worry and every passing moment, the universe remains alive with motion, mystery, and ancient patterns continuing endlessly through time. For much of human history, people searched for permanence. Ancient civilizations built monuments from stone because stone seemed eternal. Philosophers searched for unchanging truths beneath the chaos of daily life. Religions spoke of immortal realms existing beyond temporary earthly experience. There has always been something inside human consciousness longing for stability in a universe that often feels uncertain and fleeting. Yet the proton teaches a gentler lesson. Stability does not require stillness. Permanence can emerge from motion itself. The universe survives not because everything remains frozen, but because change organizes itself into enduring forms. Stars burn for billions of years through constant nuclear reactions. Galaxies maintain structure while their stars orbit continuously through space. Life persists because cells constantly rebuild themselves molecule by molecule. And deep inside every proton, invisible storms maintain their balance across cosmic time. This idea quietly transforms the meaning of existence. Human beings often fear change because change reminds us of impermanence. Bodies age, civilizations rise and fall, entire species disappear. But when viewed through the deeper lens revealed by physics, change itself becomes part of the universe's stability. Matter cycles endlessly through new forms without truly vanishing. The atoms inside your body today once belonged to ancient oceans, forgotten forests, extinct creatures, and distant stars. Someday they will continue onward into new structures again. Even now, countless particles pass continuously between your body and the world around you with every breath you take. Existence is less like owning permanent matter and more like participating temporarily in an ancient cosmic flow stretching across billions of years. And somewhere within that flow, consciousness emerged. This may be one of the most astonishing consequences of everything we have explored tonight. The proton itself does not think. Quarks and gluons possess no awareness of the storms unfolding between them. Yet through countless layers of increasing complexity, simple quantum interactions eventually gave rise to chemistry, biology, nervous systems, memory, emotion, imagination, and finally self-aware minds capable of contemplating the universe itself. The same physical laws governing the proton also govern the electrical activity inside the human brain right now as you listen quietly in darkness. Somehow, through processes still not fully understood, ancient cosmic energy organized itself into beings capable of wondering what reality truly is. There is a strange beauty hidden inside that realization. Human beings sometimes feel isolated beneath the enormity of space, as though consciousness were an accident drifting meaninglessly through a cold mechanical cosmos. But the Proton suggests another possibility. Perhaps consciousness is not separate from the universe at all. Perhaps it is one expression of the same unfolding process that shaped stars, galaxies, and matter itself. The universe spent billions of years evolving structures capable of reflecting upon their own existence. Through conscious minds, the cosmos became able to observe itself. And though human understanding remains incomplete, the very act of asking these questions may already connect us more deeply to reality than we usually realize. Even now, physicists continue searching for deeper layers beneath everything we currently know. Some suspect the proton may not represent the final level of structure within matter. Others search for evidence of hidden symmetries governing all forces in nature. There are theories suggesting spacetime itself may emerge from quantum information woven together beneath observable reality. Some physicists even wonder whether the universe resembles a kind of cosmic computation unfolding across invisible mathematical relationships. And despite all our discoveries, the largest mysteries remain untouched. Why does anything exist at all? Why do physical laws possess exactly the values they do? Why did the universe emerge capable of producing order, beauty, life, and awareness rather than remaining forever empty and silent? Perhaps no final answer will ever arrive completely. Perhaps mystery itself belongs permanently to the structure of existence. But there is comfort in that too. The proton reminds us that reality contains depths beyond immediate perception, hidden layers waiting patiently beneath ordinary experience. The universe is not exhausted by what human beings currently understand. It continues unfolding endlessly beyond the horizon of knowledge, inviting future generations to keep exploring softly through the darkness. And tonight, as your thoughts grow slower and the distant world fades gently into silence, imagine for a moment the hidden storms quietly surrounding you. Inside the walls of your room, inside the air resting softly against your skin, inside every star shining far overhead, protons continue their endless dance of confined energy. Quarks flicker through invisible seas of gluons. Quantum fields vibrate silently through empty space. Ancient particles born near the dawn of time continue carrying the memory of the universe forward into the present moment. And somehow, from all of that invisible motion, this calm, fragile world emerged. A world where conscious minds can lie awake beneath the stars and wonder softly about the mysteries hidden inside the smallest things imaginable. If you could somehow drift backward through time far enough, beyond the formation of Earth, beyond the birth of the sun, beyond the first galaxies glowing in primordial darkness, you would eventually arrive at an era when protons themselves did not yet exist. The universe then was almost unimaginably hot, dense, and violent. Temperatures were so extreme that ordinary matter could not remain stable even for an instant. Quarks moved freely through a blinding sea of radiation and energy, unconstrained by the forces that would later bind them into protons and neutrons. There were no atoms yet, no stars, no planets, no chemistry, no life, only an expanding firestorm of particles interacting continuously within the newborn cosmos. And yet hidden within that chaos were the laws that would eventually shape everything to come. As the universe expanded, it slowly cooled. And during those early moments, one of the most important transitions in cosmic history quietly unfolded. The strong force began confining quarks together into stable particles. Protons emerged from the primordial plasma like tiny islands of order forming within a cosmic ocean of energy. This event changed the future of the universe forever. Without stable protons, atoms could never form. Without atoms, stars could never ignite. Without stars, heavy elements like carbon, oxygen, calcium, and iron would never exist. In a very real sense, the birth of the proton was also the distant beginning of every future planet, every living creature, and every conscious mind that would one day gaze upward into the night sky. There is something profoundly moving about realizing how delicate that transition truly was. If the balance between physical forces in the early universe had differed even slightly, protons may never have stabilized at all. Quarks could have remained free forever inside a chaotic particle soup, preventing the emergence of ordinary matter entirely. The universe might have expanded into endless radiation without stars, galaxies, or life. Instead, for reasons humanity still does not fully understand, the laws of nature allowed stable matter to emerge from primordial energy. Tiny storms of confined quarks became the foundation of cosmic structure itself. And over billions of years, those ancient protons traveled extraordinary distances through space and time. They became part of hydrogen clouds drifting silently between stars. Gravity slowly pulled those clouds together until nuclear fusion ignited within stellar cores. Inside stars, protons collided under immense pressure and temperature, fusing into heavier elements while releasing enormous energy in the process. Every sunrise on Earth is powered by protons merging deep inside the sun. Every warm beam of sunlight touching oceans, forests, cities, and human skin began as nuclear interactions between tiny particles forged near the beginning of time. Eventually, massive stars exhausted their fuel and died violently in supernova explosions. During those catastrophic moments, new heavy elements formed and scattered outward into space. Carbon for future life, oxygen for future atmospheres, iron for future planets, calcium for future bones. The atoms composing human beings today were forged through those ancient stellar deaths long before Earth itself existed. The proton remained present through all of it, surviving every transformation while helping shape the evolution of matter across the cosmos. This means your body is not merely connected to the universe metaphorically. It is physically continuous with cosmic history itself. The particles composing your cells once drifted through ancient stars and interstellar clouds billions of years before your birth. The proton quietly erases the illusion that humanity stands separate from the cosmos. Every breath participates in processes older than civilizations, older than Earth, older even than the sun. Human life may feel brief and local from the inside, but physically speaking, each person is woven into an unfolding story stretching across nearly the entire age of the universe. And perhaps this realization changes the emotional meaning of the night sky itself. When people look upward at distant stars, they often feel separated from them by impossible distances. Space appears cold, silent, and remote. Yet the proton reveals a hidden intimacy beneath that vastness. The same physical laws operating inside distant galaxies operate inside your own body. The same strong force binding quarks inside ancient stars also binds the protons inside your blood right now. Across billions of light years, reality remains deeply unified by the same invisible principles repeating themselves everywhere. Even now, while the world around you grows quieter and sleep slowly approaches, countless invisible interactions continue unfolding beneath ordinary perception. Protons inside distant stars fuse continuously into helium. Cosmic rays race silently across intergalactic space. Quantum fields fluctuate softly throughout the vacuum of the universe. And here on Earth, ancient particles continue their endless motion inside oceans, mountains, forests, animals, and human minds. Reality never truly becomes still. Beneath every moment waits hidden movement extending across scales far beyond direct awareness. Perhaps this is why studying the proton ultimately becomes something more than physics alone. It becomes a meditation on connection, impermanence, and continuity across cosmic time. The proton teaches that the universe is not built from isolated fragments scattered meaninglessly through empty space. Instead, reality appears woven together through layers of relationships extending from quantum fields to galaxies themselves. Tiny interactions inside atomic nuclei helped shape stars. Stars shaped planets. Planets shaped life. Life evolved into beings capable of asking where everything came from. And now, billions of years after the first protons formed inside the newborn cosmos, conscious minds sit quietly beneath the stars listening to stories about invisible particles hidden deep inside matter, trying softly to understand the ancient universe from which they emerged. There is a quiet moment that sometimes arrives late at night after learning about the deeper structure of reality. A moment when the ordinary world suddenly feels unfamiliar in the most beautiful way. The walls around you no longer seem entirely solid. The air resting softly against your skin feels less empty than before. Even your own body begins to appear differently, not as a fixed object moving through space, but as a temporary arrangement of ancient particles and invisible fields endlessly exchanging energy with the wider universe. The proton changes the way reality feels once its hidden nature is understood deeply enough. It teaches that beneath appearances, existence is not static matter sitting motionless in emptiness. It is motion, interaction, relationship, endless transformation unfolding silently beneath perception. And yet, despite all this hidden turbulence, the universe remains astonishingly gentle at human scales. Oceans still move quietly beneath moonlight. Rain still falls softly against windows. Forests still sway beneath the wind. Human beings still sit together beneath the stars telling stories about the cosmos. Somehow, from all the microscopic violence unfolding inside protons and stars and quantum fields, a calm, habitable world emerged where consciousness could flourish. That may be one of the strangest facts of all. The universe contains black holes powerful enough to consume entire solar systems, neutron stars dense enough to crush atoms themselves, and quantum forces violent beyond ordinary imagination. Yet here on Earth, life exists within a narrow, peaceful interval where complexity survives long enough for awareness to bloom. Perhaps this balance between violence and calm exists everywhere throughout nature. Stars create light through nuclear fusion violent enough to transform matter itself. Yet that same light warms oceans and nourishes forests. Supernova explosions destroy entire stars, Yet those explosions also forge the heavy elements necessary for planets and life. Even the proton embodies this paradox. Inside it rages an eternal storm of confined energy, but from that storm emerges the stable matter supporting mountains, oceans, and living bodies. Nature repeatedly transforms turbulence into structure. Chaos becomes order without ever fully disappearing underneath. This realization can change how human fragility itself is perceived. People often fear impermanence because life feels temporary compared to the vast age of the cosmos. Civilizations fade. Bodies age. Individual lives pass quickly against the backdrop of cosmic time. But the proton quietly reveals another perspective. Nothing truly exists in isolation. The particles composing your body belong to countless earlier structures before becoming part of you, and someday they will continue onward again. Existence flows continuously through changing forms. Human beings are not separate from cosmic history observing it from outside. We are brief conscious expressions of processes billions of years old still unfolding through matter and energy today. And there is comfort hidden inside that continuity. The universe does not appear empty or disconnected when viewed through the lens of modern physics. Instead, everything participates in larger patterns extending across immense scales of space and time. The proton inside your body obeys the same laws as the protons inside distant galaxies billions of light-years away. Quantum fields permeate all of existence continuously. The same strong force binding quarks together inside atomic nuclei also helped shape stars, planets, and every living thing on Earth. Beneath surface differences, reality remains profoundly unified. Even human thought itself emerges from this hidden architecture. Every memory you carry tonight depends upon electrical signals moving between neurons inside your brain. Those neurons function because atoms form stable molecules. Those atoms exist because protons remain stable across cosmic time. And protons survive because invisible gluon fields trap quarks inside confined storms of energy. Somewhere deep beneath every human thought waits the quantum structure of matter itself. Consciousness may feel detached from physics during daily life, yet every emotion, dream, memory, and sensation ultimately depends upon ancient interactions unfolding invisibly inside atomic nuclei. Perhaps that is why the study of the proton eventually circles back toward wonder rather than away from it. Science did not reduce reality into something smaller and emptier. Instead, it revealed hidden depths beneath ordinary existence. The table beside your bed tonight is not merely a collection of dead particles. It is a vast arrangement of quantum fields and trapped energy stretching backward through cosmic history. The stars above are not distant decorations scattered across darkness. They are engines of matter and light participating in the same universal processes shaping every atom inside you. Even emptiness itself contains invisible fluctuations and fields humming quietly beneath reality. And still, despite centuries of scientific progress, the greatest mysteries remain open. Physicists do not yet know what dark matter truly is. They do not fully understand why the constants of nature possess exactly the values they do. They cannot yet unify gravity completely with quantum mechanics. There may be deeper structures beneath quarks, hidden dimensions folded invisibly into space-time, or entirely new principles waiting beyond current theories. Humanity stands within a universe that remains unfinished from the perspective of understanding. Every generation uncovers another layer, another mystery sleeping beneath what once appeared complete. But perhaps there is no need to rush toward final answers tonight. Perhaps it is enough simply to sit quietly with the mystery itself, to recognize that beneath every ordinary object surrounding you lies a hidden world more beautiful and strange than ancient philosophers ever imagined. To understand that inside every proton, invisible storms continue raging softly in darkness, while the calm world of human experience drifts peacefully above them. And as sleep slowly approaches now, you can let that thought settle gently into the mind. The universe is alive with motion at every scale, from distant galaxies turning silently through space to the tiny ancient particles inside your own body carrying the memory of creation itself forward through time. And now, as our journey slowly comes to its final resting place tonight, let us drift one last time toward the quiet mystery hidden inside the proton. Earlier, we began with something simple, the feeling of solidity beneath human hands. A table, a stone, the weight of your own body resting gently against the earth. At first, those things appeared obvious and unquestionable. Matter felt solid because it seemed filled with substance. Reality looked stable because human senses evolved to perceive it that way. But step by step, layer by layer, the proton revealed a different universe hidden beneath appearances. We discovered atoms made mostly of emptiness. We uncovered quarks trapped inside invisible storms of gluons. We learned that almost all the mass surrounding us emerges not from solid particles, but from energy confined within microscopic fields of force. And somewhere along the way, the ordinary world quietly transformed into something far stranger and far more beautiful than it first appeared. Tonight, you may never look at matter in exactly the same way again. The walls around you are no longer simple solid barriers. They are arrangements of ancient particles and quantum fields stretching back through cosmic history. The air surrounding you is alive with invisible motion beyond anything human senses can directly perceive. Even your own body, which feels so personal and immediate from within, is composed of particles forged across billions of years of cosmic evolution. Ancient protons born near the beginning of time now move quietly through your bloodstream. The calcium inside your bones was forged inside long-dead stars. The oxygen entering your lungs tonight was once part of older worlds, older oceans, older lives. Existence itself is not static ownership of matter. It is participation in an endless cosmic exchange unfolding across unimaginable stretches of time. And yet, despite all this motion, all this hidden turbulence, there is still peace. The universe somehow balances chaos with order so delicately that consciousness becomes possible. Tiny storms inside protons help create stable atoms. Stable atoms allow chemistry. Chemistry allows life. Life allows memory, thought, imagination, and wonder. The same forces violent enough to power stars also make possible quiet nights like this one, where a conscious mind can rest beneath the darkness listening softly to stories about the hidden architecture of reality. There is something deeply comforting about that balance. The cosmos is not merely destruction and emptiness. It is also structure, continuity, and creation. Perhaps that is the deeper emotional truth hidden inside the proton. The universe does not survive by resisting change. It survives by transforming change into patterns capable of enduring. Stars burn because of motion. Galaxies hold together through motion. Living bodies remain alive through endless internal activity. And deep inside every proton, confined energy continues dancing invisibly through the darkness. Reality is motion woven into temporary stability. The calm world of everyday human experience rests gently upon storms too small and too ancient for ordinary perception to notice. There is also humility in this realization. Human beings often imagine themselves standing at the center of existence, but the proton reminds us how vast and intricate reality truly is. Beneath every familiar object waits another hidden layer. Beneath every answer waits another question. Even now, physicists continue searching for deeper understanding beyond the proton itself. There may be unknown particles, hidden dimensions, or new quantum structures waiting silently beneath current theories. The universe remains unfinished from the perspective of knowledge, and perhaps it always will. But that is not a failure of science. It is part of the beauty of existence itself. Mystery continues expanding alongside understanding, ensuring that wonder never completely disappears from the cosmos. So tonight, as your thoughts begin growing softer and the distant world fades slowly into silence, let yourself rest within that mystery for a moment. Imagine the invisible storms continuing quietly inside every atom around you. Imagine protons born near the dawn of the universe still surviving after billions of years, carrying ancient energy forward into the present moment. Imagine the stars overhead glowing because of the same hidden forces shaping the matter inside your own body. And remember that beneath all appearances, beneath every object, every memory, every human life, reality remains alive with movement, connection, and endless transformation. Outside, the Earth continues turning silently through space. Above it, galaxies drift slowly across the darkness beyond human sight. And deep inside the smallest particles of matter, quarks and gluons continue their eternal dance, weaving energy into form across the ages of the cosmos. The proton, once imagined as a tiny solid object, became a doorway into one of the greatest revelations humanity has ever uncovered. That the universe is not built from lifeless pieces of matter resting in emptiness, but from relationships, motion, energy, and invisible fields stretching endlessly through time and space. And perhaps, as sleep finally begins to pull gently at the edges of your awareness, that realization can feel less overwhelming and more peaceful. Because it means you are not separate from the universe surrounding you. You are part of the same ancient story. The same cosmic energy flowing through stars and galaxies flows quietly through you tonight. The same laws shaping distant nebulae shape the particles inside your body. And somewhere inside those tiny invisible storms, the universe continues dreaming itself forward into eternity, one proton at a time. Top of form, bottom of form,